Montana with blowing dust. My name's Scott Lindstrom, but you're going to be listening to Paul Nutter, who's at the Great Falls Forecast Office in Montana, talking about this event and some of the impacts and some of the decisions that had to be.
Okay. All right. So are we good then?
Yep.
Okay. So so on May 24th, we had a compact closed upper low across the northern Rockies here during the afternoon hours, and that timing's kind of important as well, just because it came through with the heating of the day and enhanced the instability, allowed to help bring some of those winds down to the surface. So that lee side low deepened rapidly, produced high winds with a strong pressure gradient, and of course, as the wave went by, we had post-wave subsidence and a strong SL bar component as well that helped bring some of those high winds across the state. Basically, across the plains from north-central Montana, spreading out into northeast Montana as well. So we'll page down there. The event was anticipated several days in advance. It was a nice, well-forced synoptic system, so we had a pretty good handle on it. We, both the Glasgow forecast office as well as ourselves over here in Great Falls, we had weather stories that had been posted in advance with high wind warnings that were in effect. It started out with the typical progression from high wind watches into high wind warnings. Forecast grids contained forecast wind gusts of 50 to 60 miles an hour. The messaging, of course, was our usual kind of messaging around here. It's wide open plains. We typically don't have a lot of impacts from things like trees down or power outages or that sort of impacts that we might see further east. But around here, typically, we just try to mention that, you know, folks out there driving their camper trailers and semi trucks, things like that. We sometimes do get vehicles blown over in these conditions. There's boating impacts as we start getting into spring here as well. So we'll go to the next slide. And the one thing that's important to know, the antecedent conditions, as always, is an important element in anticipating events like this. So this has been a very dry dry spring season, especially as we get away from western portions of north-central Montana. As we move further east across into Glasgow's forecast area across northeast Montana, the percent of normal precipitation for the month of May is showing numbers here that are below 50% and in some cases below 25% of average precipitation for the month of May here. So the ranchers and agricultural interests out there, they've been struggling with their early spring seeding operations. And as well, with the dry conditions and low relative humidity, Glasgow had also posted red flag warnings. And so there was a concern for range fires on this day as well with this event coming through. So we didn't quite anticipate or didn't think about adding blowing dust to the messaging. So that's just an interesting element, kind of a hindsight thing that we probably could have done better about messaging the blowing dust potential leading into this based on the antecedent conditions here. So next slide. Okay, so on the day of the wind event, as this was coming through here, the satellite perspective, we were just kind of keeping an eye on fairly clear skies. Notice this is a dry, mainly dry shortwave. There really was very little precipitation occurring as this went by. And within the yellow circle here, first just kind of to familiarize yourself with the location, you see I labeled the location of Great Falls. I've also labeled Havre, which is in Hill County. And the Glasgow location is also marked on this map as well. So you kind of get a sense of our two forecast areas there. Within the circle, this is band 2 on the satellite imagery, running from about 17Z to about 18Z. And it's just barely discernible. If you're not seeing much, if you're really having to squint to see and kind of look up there, just to the north and east of Havre, in the left side of that circle there, you start to see some fingers of what appears to be some blowing dust. So we can go to the next slide. We've got one other perspective on this as well. One thing that's interesting, of course, since it is midday, we're not really getting the forward scattering, and that's another reason why this dust is hard to see as well. In the early part of the day or in the late part of the day, sometimes in satellite imagery we can see dust and or smoke plumes a little better because you've got enhanced forward scattering. But midday like this, it's pretty hard to pick out in the visible satellite imagery. So Tanya Franson shared this image with us from the Glasgow office, and she's got applied here a low light contrast setting on here. We sometimes use that in the winter when we have low sun angles, but it shows the dust just a little bit more clear. Again, we're still looking at band 2 here, but you're seeing a little more clearly in northeastern Hill County there to the north of Havre, kind of just left of center in this oval. You see those initial dust plumes going up until they become obscured by some low-level cumulus cloud that moved in from the northwest later in the day. It's a little hard to read in this graphic here, but I'd like to point out that there's peak winds being noted on the ASOS side there at Havre. They're peaking to 50 knots with the ASOS observation there at the Havre airport. So definitely well-timed with the strong winds. So at this point as well, we got a call from one of the forecasters who was on shift over at Glasgow. I was working with our IMED, Bob Honish, over here, and he looked at the shortwave IR just to look for heat signatures, as he's accustomed to doing for looking for wildfires, and he was able to confirm that we did not see any heat signatures in the shortwave IR. So at this point, we started to dig deeper into what we could see with the dust signatures. So next slide, please. So the split window difference is a nice tool. It's available on AWIPS. With some of the recent builds, we've started to get into looking with the GO16. We're starting to see some of these channel difference images come in. The split window difference is one of them here. And we're showing the difference between the clean infrared and the dirty infrared windows. So the spectral window difference, the split window difference, it's historically been used to detect dust, because dust will absorb to 10.3 micron radiation, but it does not absorb as well radiation at 12.3 microns. So in taking a difference there, we can see highlighted regions of dust, and in fact it shows very prominently here in this area of pink, drifting across the scene here. Some of these differences can be influenced by water vapor in the atmosphere above the dust, and those differences can also be influenced by the type of dust that's being wafted there. And one thing that I find interesting here as well is that some of the low-level cumulus clouds appear also prominently with a bright pink color to the south of where the dust plume is forming. So in this particular situation, a portion of the cloud field is appearing in the same color or indistinguishable from the dust that's further north. So as always, we have to kind of combine information from different sources to make sure that we can really characterize these events clearly. Let's look at the next slide. Another one of the channel difference products that we do have available on the GO16 menu now is also the cloud phase brightness temperature difference. We've introduced this in the system here so that we can help distinguish liquid water from ice, because the emissivity of the water cloud tops at 8.5 microns is less than that at 11 microns. So while the emissivity difference from the ice cloud tops are therefore smaller, and so typically we would use this to separate ice cloud from liquid water cloud. But in this case, we only have boundary layer, basically low-level cumulus cloud. So in a similar way, the dust appears cooler at 8.5 microns than it does at 11. And so the cloud phase difference can also be used to help identify dust. It's not as strong a signature as we saw in the split window difference on the previous slide, but nonetheless it is still here, and this time it clearly points out the fact that this blowing dust across the High Line there, across the international border, is completely different in its character than what we're seeing from the water-based low-level cumulus clouds that populate the rest of the scene here with the blue colors. So let's look at the next slide, please. So a third product that we can have as well is the dust RGB. So we start combining in different channels. I'll go over what those red, green, and blue channels are here just in a moment. Before we do that, let's just go ahead and look at this image as it loads through. The dust RGB is available in real time in AWIPS, again now as a GO16 product. It's been under development and testing via NASA Sport for several years now, and here in the Great Falls office, we're quite familiar with the image, and we've been receiving it from the Sport as they've been producing it on the Modus and Veers platforms. And so we've been testing and evaluating, providing some feedback to the Sport office over a number of years. So when I got a call from Glasgow, and they started asking, well, is it smoke? Is there a grass range fire going out there, or is it dust? I immediately turned to the dust RGB, and to me, I'm familiar with looking for the pink signatures that you do start to see emerging across the international border area there north and east of Havre. So the pink signatures are the dust, and we very clearly see that that's different and distinguished from the low-level clouds that appear here in the kind of tan-orange colors as well that we're seeing there. So let's look at how this is composed if we go to the next slide. So the dust RGB is combining the split window difference. It assigns the signature from the split window difference to a red color in the image there. So it also then takes the information from the cloud phase channel difference and assigns that to green, and then it gives it a thermal contribution as well by just applying the clean IR band there into the blue channel. So if we look at the next slide, we'll highlight the fact that we use a little blue box here to outline the fact that the range of brightness temperature differences, all these different channels, they've been scaled to a fixed range of brightness temperature differences. The band differences are based on those which were developed at EUMETSAT, but then Sport has since reconstructed and kind of reinvented them slightly, with slight differences to be applied to the GOES advanced baseline imager, just because there are slight differences in the precise definition of the center wavelengths there. So there have been some slight adjustments, but for the most part, this is a well tested RGB that's been in use for years, developed out of best practices from the EUMETSAT folks over there. So it is a fixed range, but what's nice about this is that these are all long wavelength components, and so this RGB is valid during the daytime as equally as it is during nighttime. So it's a 24-hour useful RGB, just as are the channel differences themselves, but when we combine them, we also can use this RGB 24 hours a day. The last little piece to this is we'll just point out there's a gamma adjustment to this. If we go ahead and go to the next slide, in particular on the green, there's a 2.5. It's an exponent that's applied to the scaling here, and basically it just moves the contrast a little closer to the higher end of the scale there in the green. And basically, in short, that's how that was developed. And the Sport website provides references and quick guides to help guide if you want to read more about how that's developed. So applications, of course, what did we do? Once we started identifying this was definitely dust, we called, tried to reach out to a few spotters, and we finally reached the port of Wildhorse on the international border. They did, in fact, verify we had zero visibility or near zero visibility, at which point we issued a special weather statement, and we posted some statements to social media, including, you see our example that we posted to Twitter here. We also posted something similar on Facebook. Within the special weather statement, I'd like to point out, I have the text here in front of me, and one of the sentences there, we said, satellite imagery indicates several areas of blowing dust. So we were able to directly translate the availability of the satellite imagery into our special weather statement. Next slide. So what did we see on the ground? Well, again, we turned to Twitter to get some of those photos. This was a little bit further north up into Saskatchewan, but we have a nice, basically a leading edge of a dust plume showing up here, and from a Twitter user. So we can go to the next slide again there for a few more pictures. There's a video here. And you can kind of get a sense from the ground looking up through the dust. It's very much a low-level effect. You can see the clouds above the dust field. From the ground, it might be hard to estimate the depth of the dust layer there, but The report that came in with here with this Twitter was an estimate, or I guess he had a weather station there that measured 98 kilometers per hour, which you can translate over to 61 mile an hour winds. So quite an impact there. Let's go to the next slide. And the result that was posted after the event was erosion. He makes the comment, 34 years of zero-till soil building, and in 10 minutes it scarred away portions of his field there. And you can see that with a little sample of a plant on the right there, that it was eroded down from, eroded and exposed a portion of the roots there on the crop they're growing there. So let's see next slide. And so the bottom line here is that, that dust signal, we started out with the visible satellite imagery. It was a very subtle signature there. But in fact, when we come through to the end of the cycle there, we find out that indeed it had very large agricultural impacts. And that can be certainly very important, especially when we're in an environment where we've had well below average rainfall across the area in a dry land farming type community out here. So big economic impacts as well. So those brightness temperature differences and as well the dust RGB, they were all very helpful in allowing us to monitor that dust over 24 hours and can be used in any 24 hours if we need to. So the next slide, I think that's all I have at this point to summarize that event.
Are there any questions for Paul? First of all, thanks, Paul. But are there any questions?
This is Bernie from Sierra, and I have a question in terms of, like the agriculture impacts, though. For, say, you showed the example of someone commenting about no tilling and the soil gone. So it affected even areas that hadn't been tilled. Is that correct? And from that, I would say that can anything be done even if you had warned a day ahead of time?
Well, that's a good question. Certainly I can't claim to have a lot of expertise in agriculture there, but it's my understanding that a lot of these folks are trying to avoid tillage of the soil to maintain healthy soils and root structures and bacteria in the soil and so forth. But, since it's basically a dry land agriculture out here, it's not irrigated. I don't know what they might have been able to done if they could have done anything in advance. I don't know, but I would speculate there is nothing they really could have done preventative-wise.
Okay, thanks. And yeah, so essentially when you showed the RGBs, the range that they're using in the RGBs is a lot narrower than what you were showing earlier for just the straight differences, correct?
Yes, that's correct.
Yeah, I guess that was Scott or Dan replying there.
When you look at the split window difference in AWIPS, and I'll also comment that when I made that screen capture, the default color enhancement was different than the default color enhancement that's in AWIPS now. But when you look at the split window difference, the range, or the cloud phase difference, the ranges in there are greater than the ranges that are used in the dust RGB.
Yeah, I was just clarifying that and then pointing out that that's another reason why the RGB might pull out the signal a little better.
Okay.
Are there any other questions? Well, hearing nothing, I will comment that we have another webinar in 2 weeks from Memphis on